Hi, good afternoon. I want to introduce the lab for this week, which is lab 3, which is vector addition. Just pay attention as I'm gonna view the lab and talk about some of the things that really important. You're going to find, of course, I will split this to week 4 lecture and week 4 lab. Now, you're gonna see that for week 4 lab, you are going to see a requirement to complete one item. That complete one item means you should view the video. Otherwise, that lab will not open for you. Also, you should watch the whole video. I'm gonna check it, and also I added to the rubric here that you should watch the video, or if it is I will say remote class, you should be for the whole period of the time when we have our lab remote. Okay, but for you were able to view the add-in vector video, and I can check it, and not only just view 5 minutes of it, you should watch the whole video, and I have a way to to check that. All right, then this is one thing. Now let's go back to I will say the lab itself and talk about how we are going to do this lab. This lab is not going to be a formal lab report, and you will not submit abstract data, whatever, like all the things here. This is going to be, you have to submit this handout, the same one. You can of course download. You should have a cover page. It should be all typed. You will not be able to submit anything handwritten. I will not accept it. You will not use also the lab template. Okay? Now let me tell you how we are going to work with the lab. Now that we are going to use today 2 simulations. I will not use the vectors here. I want to show you how I can add vectors, okay, from that simulation. You're gonna access the lab, and here it's very important. You need to work either, you cannot combine both. Either you're gonna use the orange one or the blue one. Okay, I prefer, my favorite is the blue. Then this, let's assume my vector, this was my vector, it was 10.4 and it has an angle 16.7. all right, and then I have another vector. Then I'm gonna put that vector with, let's say it is 118.6 the angle, which is this one, and it is 12.5. Then I'm gonna put it tail, head, tail, head. Now my third one, okay, I'm gonna assume I have something like this. Now look here, this is 7.6, and the negative 156.8 is gonna be the angle from the x-axis clockwise. Then this is the angle. In my instructions, I'm giving you the other angle, this one. Then you need to subtract minus 360. Okay, then again, now here you can see that this vector has an angle negative 156.8. That is measured from the positive x-axis clockwise. Okay, my angles, they are not be negative, they will be positive because I am measuring in this direction. Then you need to subtract, you need to have your angle minus 360 to get what is going to be the angle on the simulation. Now let's assume this is my fourth one. Okay, for you I think I put like 3, but let's assume here we're gonna have a fourth. Then this is, and then for the resultant I will hit that sum, the blue for the blue and the red for the orange. Now look here, this is my resultant. which is 8.6, and it has an angle with the positive x-axis 144.5. Then here I am able to determine the magnitude of the vector as 8.6 and its direction determined by the angle 144.5. You need to take a screenshot of that and insert in your lab report, in your handout here. Okay, then here you're gonna say what is the resultant from the simulation, magnitude and direction, and then you are going to insert your resultant, your screenshot here. This is task 1, and here what we did actually is we added graphically. Now part 2 or task 2, you have the same vectors. You need to add them using by component method. You should show all your details of your calculation, and that is going to be using your calculator. Then you're going to say here, this is vector A, like we did in the lecture. The magnitude is 5.80 meters per second. The angle is 31.0. Then here I have A times cosine theta, and you're going to calculate the x component, and then you're going to say here A times sine theta. You are going to move to vector B and say its magnitude is 6.7 and the angle is 116.9. You're going to find the x component, the y component, and here also for C, you are going to find what's the magnitude, what's the angle, and then you are going to say here the x component is C cosine theta and the y component is C sine theta. You're going to add all the components here to get the Rx. You're going to add all the y components here to get the Ry. And then you are going to use the Pythagorean to calculate what is R. R is the square root of Rx squared plus Ry squared. Also, you need to find the difference. You need to find the angle, I mean the direction. Now, this one here, it is the percent difference between your results from task 1 and task 2. Then you need to compare, find the percent difference between the two values. Consider the first one as theoretical and the second one that you have calculated as experimental. And you need to find the percent difference for two quantities. One of them is the magnitude and the other is for the direction. Then these are task 1 and task 2. Now there is another simulation that we are going to use, and this is, like I will say, very straightforward here. You're going to use a vector that has a magnitude 62.5. And every time you are going to use a different angle, and just here using the simulation, you're gonna have your vector A1. It's in the first quadrant and it is 32 from the positive x-axis. You're gonna, from the simulation, look at what is the x component and what is the y component. Let me show you what do I mean by this. Here I'm gonna change. Okay, I'm gonna have my vector, I said 62.5, right? All right, and then I'm gonna here have, I want to have 32 for the angle 32. Actually, you can do this here, I believe, like, oh no, this one is different. Okay, then now here, look, it's giving you what's AY and what's AX. Now, the second one I'm asking you, it's in the first quadrant, but now it is 32 from the y-axis. Then, okay, the angle that you're gonna measure here, it should be 90 minus 32, which is 58. Then you're gonna say here, this should be 58. And then you are going to look at what is the x component and what is the y component. Now is going to tell you the next, it is again 32 from the y-axis, from the positive y-axis, but it is in the second quadrant. This means that the angle here is going to be 32, and therefore the angle for my vector is going to be 90 plus 32, which is 122. Then here I'm going to see my angle as 122. All right, then now look here, this one here is 32. You're gonna continue working with this, and you need to find out what is really the angles that you are going to deal with based on the quadrant and based on the angle from the axis, and you're gonna just record the values that you're gonna see here. Now I want you to look here, when that AX is along a negative, the simulation is giving you 33.3.1, but it should be negative. You should show me this on your table that this one should be negative. And when I will move maybe to here, you need to reflect always what is the signs of the x component and the y component. This is task number 3. And that, as I said, you're gonna fill in these all from the simulation. Here, what you are going to do is you are going to have the same vector that we were talking about in task 3, but you're gonna do the calculation using your calculator. Then here, you are going to use your calculator to calculate the components of each vector. And just here, this is going to be calculation, and again what is really required here is typing. Then I will say again, let me download here and show you. Okay, like this is my document. Of course, this document you can edit. And where I was, yeah, we did practice this in lab number 1, how to use equations, but again I can download it and I can insert an equation. Then I can say here a 2x, like here I can say okay, just you're gonna type in okay these, okay, and continue working with that. Is gonna be a2 just be capital A2 times cosine, and go on this calculation all. Okay, then this is really the lab, and you need to fill in what is really required. And thank you very much for listening.